So today we're going to talk about basic counting. The four topics in this section are going to be the product rule, which comes from and, the sum rule, which comes from or. We're going to have inclusion, exclusion, which is going to kind of deal with not really. It's more about unions and intersections, but we're going to kind of think of and, or, and not. And finally, the division rule, which is going to deal with symmetries. Now, product rule, sum rule, and inclusion and exclusion will be in this video. Symmetries will be in the next video. Okay, so let's do an example of the product rule so you can see how it works. Rather than me stating it in general, I just want to show you an example, and then I think it'll be clear how the product rule works. So example, obviously I'm the most fashionable person that any of you have ever seen, and you're clearly curious how I get so fashionable. Well, let me give you a peek into my closet. I have 3 shirts and 2 pairs of jeans. And of course the question is, how many outfits can I make? So once you know the answer to this question, then you'll have just a little bit of a view into my amazing fashion sense. So what we're going to do is we're going to let S equal a set of shirts, A, B, and C, and we're going to let J equal the set of jeans, X and Y, and we're looking for how many ways can I pair up elements in this set with elements in this set. That's really what the question is asking. How many outfits? How many ordered pairs, A on top, X on bottom, or C on top, Y on bottom, right? So I have to choose this, and I have to choose that. Well, let's look at the Cartesian product. So S Cartesian product with J is going to be, I've got A paired with X, I'm going to have B paired with X, and I'm going to have C paired with X. Then I'll have A paired with Y, B paired with Y, and C paired with Y. Now, I've made this in kind of a strange order so that you can see the size of the Cartesian product is really 3 times 2. So recall, in general, that the size of the Cartesian product, A times B, A cross B, is the size of A times the size of B. So for us here, in this case, we have the size of S Cartesian product with J is going to be the size of S times the size of J. So the answer is going to be 3 times 2, which is 6. That's our final answer for this question. And that's just the basic, the most basic product rule. The idea is I have to do this thing first. I have to do this first thing. And how many choices do I have for the first thing? Well, let's suppose the first thing I do is put on a shirt. I have 3 choices for the first thing. Then I have the second thing that I do. How many choices do I have for the second thing? Well, let's say the second thing that I'm doing is putting on a pair of jeans. So I've got 3 choices for the first thing, 2 choices for the second thing, and the total number of choices is going to be 3 times 2 because of this Cartesian product structure. So I'm to do something and something else, I multiply those together. So I'm going to get 3 times 2 for a total of 6 different outfits. So let's do a different example. Of course you can pause or rewind if that was too quick. But I really think that seeing a few examples will help. So next example, and this is going to be, we're going to go to binary numbers. How many, not binary numbers, bit strings. How many bit strings of length 6 are there? And the way I want to do this is I want to think of, I could view this as a Cartesian product of 6 sets, 0, 1, cross 0, 1, cross, ... 6 times. But, and that is totally what's happening. But another way to think of it is I have to choose my first bit, and I have to choose my second bit, and I have to choose my third bit, and I have to choose my fourth bit, and I have to choose my fifth bit, and I have to choose my sixth bit. So how many choices do I have for the first bit? Well, if it's a bit string, a binary string, it's either 0 or 1, so I have 2 choices for the first. Then the next binary digit, the next bit, is either 0 or 1. Again, I have 2 choices for the second, 2 choices for the third, 2 choices, 2 choices, 2 choices. I'm multiplying because I have to do this and this and this. It's ands all the way across. It's not like I could pick earlier binary digits and then ignore picking the later ones. I have to do all of these. So since I'm using an and in my process, the total here is going to be 2 to the 6th. So it might not quite be clear why we're using and as opposed to or just yet. But hold on, and let's look at this next example, and then we'll get into the or stuff after that. So if this doesn't totally make sense, I would say, maybe try to watch it one more time. If it doesn't make sense yet, just watch past, look at the next stuff, and hopefully when you compare and contrast what's happening between these first 2 situations, the anding versus the oring, which is the multiplying versus the adding, should make some more sense. So the next question is, how many bit strings of length 8 end in 1, 0? So how many bit strings of length 8, but I've specified what the last 2 bits are? Well, this is going to be 2 choices for my first bit, 2 choices for my second bit, 2 choices for my third bit, 2 choices for my fourth bit, 2 choices for my fifth bit, 2 choices for my sixth bit. But when we get to the 6th bit, that's the last time we get to make a choice, because the 7th bit has to be a 1, and the 8th bit has to be a 0. So I had 1 choice here, because it had to be a 1, and I had 1 choice here, because it had to be a 0. So the answer is, again, 2 to the 6th. Because I've got 6 choices to make, and these choices are already made for me. So I choose this, and I choose this, and I choose and all the way down. So if I'm fixing the last 2 bits, then this is still essentially a 6-bit string.